On May 14, 2026, a company most people had never heard of walked onto the Nasdaq and pulled off the largest American tech IPO since Uber. They raised $5.5 billion. By closing bell, the stock was up 68%. 2 engineers became billionaires overnight. The company was worth $95 billion. This is what they sell: a single computer chip, the size of a dinner plate. 4 trillion transistors carved out of one uncut silicon wafer. It is the largest chip ever made. For comparison, this is an Nvidia H100, the GPU that powers most of the AI you've ever used. And this is a Cerebras wafer. Same silicon, same fab, roughly 57 times the area. Cerebras was founded in 2016 by 5 engineers who had previously built a company called C-Micro, sold to AMD for $355 million. They reunited around a single, almost reckless question: what if you simply didn't cut the wafer? To understand why that question matters, you have to understand the memory wall. Modern AI doesn't fail because chips can't compute fast enough. It fails because chips can't feed themselves fast enough. In modern silicon, a floating point multiply costs about 3 picojoules of energy. Reading that same number from external memory costs around 640. Moving data is 200 times more expensive than computing on it. The bottleneck isn't math, it's the wire. So Cerebras shortened every wire. 900,000 tiny cores, each with its own local memory, all sitting on a single uncut wafer millimeters apart instead of meters. They worked with TSMC to repurpose the scribe lines, the gaps where wafers are normally sliced, as data highways. Cores across the entire wafer now communicate at the same speed as cores sitting next to each other. The result: roughly 21 petabytes per second of on-chip memory bandwidth, about 7,000 times more than a top-end GPU. For workloads that are starved for data, which, increasingly, means all of modern AI, that's the entire ballgame. Of course, a chip this large breaks every assumption of conventional packaging. 20,000 amps of current, 20 kilowatts of heat. Power had to be delivered vertically through hundreds of regulators. Cooling required a custom water-cooled cold plate. They had to invent the manufacturing line to build it. What they got in return was a machine that can run a trillion-parameter AI model on a single chip. No cables, no networking, no sharding. Inference speeds that GPU clouds physically cannot match. Their largest customer is G42, the Emirati AI giant, building a network of supercomputers called Condor Galaxy. It is, by some measures, the most concentrated customer relationship of any major chip company in the world. And that's the bear case. Wall Street analysts called the technology niche, brilliant but rigid, expensive, built around a software ecosystem that doesn't yet rival CUDA, a bet on a future that hasn't fully arrived. But the physics underneath the bet is real. The memory wall is real. The cost of moving a bit is real. And if the future of computing really is bound by how fast you can feed a chip its own weights, then $95 billion may turn out to be the floor, not the ceiling.